Hi, my name is Sydney with Utah Water Watch. Welcome to the Salinity Monitoring training video. Salinity is the concentration of dissolved salts in water. Salinity is important for aquatic organisms because it affects the functionality of many biological processes involving membranes, such as gills or eggs. Aquatic organisms have evolved to withstand and live in a specific range of salinity, and the presence or absence of specific organisms within a water body may be an indication of the salinity. The salinity of natural waters is affected by many factors such as the underlying geology of a drainage area. The underlying geology of a drainage area can affect salinity based on what the geology is. If it is a hard rock, such as igneous or basalt, it will erode a lot slower and take a lot more time for the minerals to get into the water, thus causing it to have a lower salinity. A higher salinity would be caused by a drainage area composed of sedimentary rock or limestones that break down a lot faster and dissolve and create a higher salinity. Salinity of water in lakes and streams is also affected by the origin of the water. For example, if water from a well or groundwater is measured, it will have a higher salinity than surface water because the water is in bedrock and sits for a lot longer surrounded by minerals and absorbs more minerals. Whereas surface water, where with streams fed through runoff or precipitation, will have much lower salinity. The length of a stream, soil and climate conditions, time of year, and temperature also all have big influences on salinity. Temperature notably has a large influence on salinity because the higher the temperature is in a body of water, the faster and more likely minerals are to dissolve in the water, causing higher salinity. Conductivity measurements taken with the Utah Water Watch meters are calculated using microsiemens per centimeter. This is done by running a small electrical current from one end of the probe to the next. TDS measurements on the Utah Water Watch probe are taken using parts per million. Parts per million measurement given by your probe is then converted into milligrams per liter. For the Utah Water Watch, the conversion of parts per million to milligrams per liter is a 1-to-1 ratio. So 1 part per million is equal to approximately 1 milligram per liter. To start, you'll turn the meter on and the display will turn on. To change the mode, right now it's on ppm. And to change your units, you hit the mode button to change it from parts per million to microsiemens per second to degrees Celsius. When you're ready to collect your salinity sample, you want to find a spot at your site where you can collect a sample that is representative of the entire site or water body. So in a stream, that would be closer to the center. You're going to want to start with your plastic cup and rinse it out 3 times. Once you've collected your sample, take the cap off the end of the meter. Turn the meter on and place it in the sample in between the minimum and maximum lines on your meter. It can take a minute for the reading to stop moving up and down on your meter. It can take up to 10 or 30 seconds. Once the values on your meter have stopped going up and down, press the hold button to freeze the value on your meter. Then you have up to a minute to record your values before the meter changes. To toggle between parts per million, microsiemens per second, and degrees Celsius, press the mode button. You'll want to record all 3 of these measurements on your Utah Water Watch user data sheet. Once you are done recording your measurements, shake off the meter to get any excess water off, turn it off, and cap it. Before monitoring each month, be sure to check the calibration of your salinity meter. A video with instructions for how to check this calibration can be found on our website. Thanks for watching the Salinity Monitoring training video. If you have any questions or concerns at any time, feel free to reach out to Utah Water Watch staff through phone or email. Happy monitoring!